We continue with example 3 under RL circuits for Kirchhoff law. The question is, a resistance of 100 ohms and inductance 5 henries are connected in series with a battery of 20 volts. Find the current at any instant if the relation between L, R and E is given by L di over dt plus IR equals to ET, right? To solve this question, first we extract the given information, which is L, R, and ET. Okay? Right, we have L, R, and ET. Okay? So from the given question, a resistance of 100 ohms. Okay? From here, this is R. Okay? So we can put the value of R equals to 100 ohms. Right? And then from the word inductance, 5 henries. So we can put here, okay, L equals to 5 henries, okay. And then battery of 20 volts, okay. This is ET, okay. So we can put the value of ET equals to 20 volts, right? And then the question is, find the current at any instant, okay. Means we need to find IT, okay? I means current, and then at any instant means current in terms of any time t, okay? And we can use the initial condition when time equals to 0, the current equals to 0 ampere, okay? This initial condition is to find the value of C after integration, right? Because after we integrate, using indefinite integral, we need to put plus C at the back. And to find the value of C, we use this initial condition, right? After we extract the values of L, R, and ET, then we can start with the given formula. From the given formula, L di over dt plus IR equals to ET, this is RL circuit formula under Kirchhoff law, okay? So we substitute the values of L, R, and ET into this formula. So after we substitute, we got this, okay? L equals to 5, okay? R equals to 100, and ET equals to 20, okay? After that, we need to write coefficient of di over dt equals to positive 1. Okay? To write coefficient of di over dt equals to positive 1, we need to dividing each term by 5. Right? So after we dividing each term by 5, so we got this. Okay? di over dt equals, di over dt plus 100 divided by 5 equals to 20, and then I equals to 20 divided by 5 equals to 4. Okay, so after we done write coefficient of di over dt equals to positive 1, then we can compare with linear equation formula. Okay, under linear equation formula, we have dy over dx plus bxy equals to qx. Okay, when we compare, okay, variable I here is similar to variable y, right? And variable t here is similar to variable x, okay? I means current and t means time, right? Alright, we recall back under linear equation, the most important part is to find IF, okay, which is integrating factor. And IF equals to IF equals to E to the power of integration of px dx. So from this linear equation, in terms of variable t and variable I, when we find IF, okay, it is equals to E to the power of integration of 20. 20 here means px, okay? In this case means pt, okay? And then we integrate with respect to t, right? Because now our dx now is similar to dt. Okay, and when we integrate constant 20 with respect to t, it is equals to 20t, okay, plus c. But we don't need to put plus c, okay, because we still not finished solve this question, okay. Alright, so from here we got if equals to e to the power of 20t, okay. And then after we find if, we need to find the solution, okay, the general solution. From here, our I here means similar to y, okay. So from linear equation formula, y times if equals to integration of qx times if df. Sorry, if dx, right? So y here means variable I, which is current, okay? So we can write I, okay, times if. Our if equals to e to the power of 20t equals to integration of qx. Our qx equals to 4. And then times if equals to e to the power of 20t. And then our dx now is similar to dt, okay? Right, on the right hand side here, we have integration sign, so we need to integrate, okay? So on the left hand side here, we still have I times e to the power of 20t equals to, we have constant in front here, 4, and then times, after we integrate e to the power of 20t with respect to t, we got e to the power of 20t over 20. Okay, and then since this is indefinite integral, we must put plus c at the back, right? After that, okay, from here, we can simplify 4 and 20 in denominator here, okay? So after we simplify this, we got 5 in denominator, okay? So we can write I times e to the power of 20t equals to, okay, 0.2, okay? 1 divided by 5 equals to 0.2, and then e to the power of 20t, and then plus c, right? And we can name as equation 1, okay? Alright, so from here, after we integrate, we got plus c here, and to find the constant c, we can use this information, okay? When time equals to 0, the current equals to 0 ampere, okay? So we can use this information to find the value of c, right? So from t equals to 0 and I equals to 0, after we substitute into equation 1, so we got this, okay? 0 times any value equals to 0 equals to 0.2 e to the power of 0 plus c, okay? E to the power of 0 is not equals to 0, but it is equals to 1. So 1 times 0.2 equals to 0.2, okay? So we can write 0 equals to 0.2 plus c, right? Then we can solve for c, okay? C equals to negative 0.2. Then we substitute the value of c into equation 1, right? So after we substitute the value of c into equation 1, we got this. I times e to the power of 20t equals to 0.2 e to the power of 20t minus 0.2, right? To find the current at any instant, we need to write I as a subject, okay? So to write I as a subject, we need to move multiplication of e to the power of 20t to right hand side. Since this is multiplication operation, so after we move to right hand side, we can dividing each term by e to the power of 20t like this, right? So from here we have I equals to 0.2 e to the power of 20t over e to the power of 20t minus 0.2 over e to the power of 20t. Okay, and then from here, okay, we can simplify e to the power of 20t from numerator and denominator. Okay, so the current in the circuit at any time t is given by I equals to 0.2 minus 0.2. From here, we can move denominator 0.20t. We move up using properties of indices. So we can write 0.2 times e to the power of negative 20t. Okay, this is the current in the circuit at any time t, or the current at any instant. Right? Got it? So this is the complete solution for this question. Right? Coming up next, Kirchhoff Law, more examples. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.